Okay, I'm going to recording and going to share the screen. And first, what we will do is last class, I remember we already started discussing about feature selection, but we didn't get a chance to go over the Jupyter Notebook example. So today we are going to first start with the example. Yeah, with the for the data pre-processing cleaning part. And let's see, this example is also on our course website. Okay, so after class, you can also review it. So first, let's take a look. So this is a simulation of the CSV data. Okay, it's not from a file. So it's, you can also do read a CSV with like a string IO, okay, get that CS. Basically, this is string, is it? And but it's formatted as CSV file, okay. And then we get the data frame. So we all know this, nothing new. And then what's next, because for machine learning, you need to use all of the data to do certain calculations. So you need to deal with the null values. So that's why the next cell is check about the null situation, is it in your data frame. So if you do something like this, it will list out like on each column, is it the number of null values. And then over here, you can also find the corresponding values regarding the data frame. And sometimes we need to deal with the missing data, is it? So the drop NA, previously we also learned, is it? So in this case, if you want to drop some null values, is it? In this case, drop the rows, is it? Then you can just do the drop NA and specify the axis as 0. So that's mean you want to drop by rows and look for the null values. And if you want to do by column, then you specify axis as 1, okay? And for drop NA, you can also specify the condition is by any or by all, is it? Over here it says, okay, unless the whole column, is it, is all, then you are going to drop it. Otherwise, you're going to keep them, is it? So that's the case. And you can also specify the threshold, is it, to see if you want to drop. And you can also specify like which column, is it, based on which column, and you're going to do the drop NA. So that's all about the general information, and pretty straightforward. And we all already learned of those starting point knowledge. And what next, what we will learn is the sklearn package. In the pre-processing, you can use imputer, okay, to impute some missing values, okay. Here it says impute via what? You can use in column mean. Column mean. So let's see, how do we do that? Is it, so in order to do that, what you can do first is you need to create an object of the imputer. So you create an imputer, is it? And then you specify what you consider as missing value. So here in this case is, you say, oh, I'm going to consider the null value as a missing value. And you're going to replace it with what? Is it? So here the strategy is that I'm going to replace with the mean value. I'm not going to drop it. Is it? I'm going to replace it with mean value. And you also specify along row or along column. Is it? So here it says, okay, I'm going to do the imputing along row. Is it? After that, then you can call fit with your data set, is it, with your data frame in this case. And after that, then you can call transform. So this is pretty similar as what we already learned from of the other sklearn module, is it? And then here you see, after you do the imputing, is it? Here it shows the data, is it? So the nav value is gone, is it? But it's replaced with what? With the mean value. So that's occurred a lot of times when you do machine learning, because you don't want to, in case there are a lot of nav values, if you drop off them, then you're going to lose quite a number of data sets, the number of data from your data set to do training and testing, etc. So you need to find some way to deal with the missing value, etc. So one of the way you can do is from sklearn package. Remember, it belongs to pre-processing part and using the imputer model, okay? And then you can specify your strategy to deal with the missing data, the nav values. And what next part shows is how do we handle categorical data, okay? And on the category is the nominal or ordinal, okay? How do we deal with it? So let's take a look. So for this data frame, we create a data frame, is it? And then you can specify the column name. So here is a data frame, quite a simple one. And within this data frame, we can see not all of the columns, is it, are value, is it color and size, the not numeric value, the strings, is it? So with what we already learned, the machine learning model, some of them you cannot do with this, is it? You need to do certain kind of conversion to convert them to numeric value. So how do we do that? Is it? So let's see. So in this case, like the t-shirt size, as if for t-shirt size, normally XL, L, the extra large, large, or middle, is it medium? And then you can specify some with some number to represent it. Is it? So here you use dictionary to create this mapping, is it? And then you can redefine that column of that data frame, is it? And you just call the map function with this dictionary, is it? And if you recheck the column of the data frame, the size column, now it's changed to numeric value, is it? Numeric value. So this is one of the case of the categorical data. Okay, so the size so belongs to categorical data, but this categorical data is what? It's ordinal, is it? So you can use a certain number to replace it. And what next? Let's see. You can also kind of, here it says, a lot of time you want to reverse it back, is it? After you change your data set, is that you want the output, then you don't want number, you want to still the string, is it like the extra large or large or medium? Then in that case, you can just do the map again with the reverse mapping. Basically, it's still just that dictionary. Okay, that's one of the case that we learned. Next, let's see the class label. Is it in this case, the class label is still strings. Is that class 1 or class 2? Is it? And when we do machine learning, we know the target value y. Is it that y vector? It also needed to be number. Is it? So over here, we can also do the conversion. Is it? And here it shows a couple of ways you can do. So first, let's take a look. So what here you're going to do is, here we have the loop, is it? And what this loop does is going to check your class label column, is it? On that column, then you find all of the unique values, is it? From that unique value, then you can create a map of the label and the corresponding number, because the enumerator returns number, is it? So you will have a tuple that has the number and the corresponding label, is it? And then you're going to reverse them as the dictionary of label and the number, is it? So what the result gives you is a dictionary, okay? With that dictionary, then you can redefine that column that calls a map function, okay? And then in this case, you can find, yeah, the class label now it's changed to 0 and 1, so to numeric values, okay? And what next shows is the same thing. You can also reverse it back to the string, etc. So similar skills. Okay, then next, what it shows, we can also use another module called label encoder. Okay, label encoder. So let's see, how do we do this with the label encoder? So with the label encoder, then it's the same thing. Whenever you use sklearn, it's always the first. You need to create the object, okay, for that module. Then you call transform. And this time, what you're going to transform is regarding the class label column, and then you can see, so in this case, you don't need it. So the previous way we learned with the mapping is with the dictionary, you hard code it to do the string to numeric value conversion. Here, if you use sklearn pre-processing package, and if you use a label encoder, it will do the work for you automatically. So here it shows, yeah, did you see the target vector y, it has 0, 1, values. And if you want to reverse back, you can just call inverse transform, and then it will reverse back whatever the string original is, okay? So this just shows you can also use sklearn's label encoder, okay, label encoder to do this job. And what next is, this is also quite a useful concept. It's called one-hot encoding, okay, on nominal values. So what does that mean? Let's take a look. So this time, what we have is we have the data frame. So the your sample is from the data frame's color, size, and price. And then you create a label encoder object, okay? And then you can start to fit, fit with the data with the label encoder. So in this case, it will do the automatic conversion if you take a look at the result regarding previously. Previously our that DF, the data frame, it shows like this, the original. The original is like this. This is the original data frame. Color and size and class label, they are not numeric. And what here we did is you call the label encoder, and then you can call the fit transform to convert off the data, the samples part, the sample part of the, and then did you see the color and the size? Both of these two columns converted to what? Converted to numeric. Converted to numeric? Okay, so label encoder, we can say it's quite useful, can help you to convert non-numeric data to numeric data. And we have another important module. It's called one-hot encoder. Okay, one-hot encoder, what does it mean is, if you take a look at the result, is for this one-hot encoder, what we transform our previous, the x value, x value, it's changed to what? If you take a close look, you will find this is the last column, that's regarding price. So this is price. Okay, this column is the size. But if you take a close look, you will find how can it come up? What are the new columns? Where did it come from? Because previously you only have, so this is for color column. Now you have 3 columns. So what's the relationship between those two? is it? So this concept is called one-hot encoder. Okay, one-hot encoder, the idea is if we take a look, previously for our color, is it we have three color. We have green and red and blue. Green, red, blue, is it? So that's our previous one. Okay, so let's. So previously we have a green, red, and blue. Is it RGB? We have this three string word for the color column. Is it? And you use the label encoder. Is it? And it converted to number. Is it 1, 2, and 0? Is it? And that doesn't make a lot of sense if you have a lot of strings to deal with, okay? Because the number has a scale, okay? And regarding color, like a green color or red color or blue color, so this is not like size. So how can you see who is larger and who is smaller? Is it not like size? For size, of course, XL is greater than L is then greater than media, is it? So that's why you have 1, 2, 3. That makes sense. But here, among the color, and for color code, we have 0 to 255, is it? So how can you color code all of this? It doesn't make sense to have a larger number or a small number, is it? So what here we do is you kind of create 3 new columns. So green column, red column, and the blue column. Okay, and then regarding this, okay, the first row, because it's green color, is it? Okay, so only green color set as 1, and the other two not occurs here, so that's why you set as 0, is it? And the same idea, okay, for the second row, it's the green color, or it's a blue color, is it? So that's why only blue is set to 1, the other two set to 0. And for the third one, it's green color, is it? So that's why green set 1, the other two set to 0. So that's why we call this method as one-hot encoder. Okay, so it's one-hot encoder. You set up to 1, and of the other, you set it to 0, but you expand the columns. Is it? Convert from previous single column to 3 columns, okay? So that's the idea about one-hot encoder, okay? And the one-hot encoder, and then you can call feed transfer, so it gives you this result, okay? And there is another way with pandas. We can much easier to do this, not using the one-hot encoder. And it's called the getDummy function. Okay, so what a getDummies function, if we take a look at the result, you will find, yeah, did you see for the color one? It adds 3 new columns, is it? And this 3 is color blue, color green, and color red. And it only has 1 or 0, is it? So getDummy function can do the similar thing as what we called one-hot encoding, okay? So one-hot encoding using getDummies through pandas is pretty easy to be achieved. And over here it says you can also do multi-collinearity guard. And if you want to do that, you can set up the option, we call it drop first as true. Okay, so if you set up the drop first as true, then in this case, this time, did you see, you only have 2 columns, is it? Green, red, you don't have blue, is it? So if you take a look at the last row, the third one, it's all 0. So by default, then you know, okay, this one is blue. Okay, so you can also do this, okay? And what the next one shows is similar thing. You can do using one-hot encoder module, okay? with one hot encoder module. And then you can do the similar, so that the default one just has 0, 0. That means it's going to be the default blue one. Okay, so that's regarding the categorical data. How do we convert categorical data to numerical data? Because in machine learning, you do need numerical data to train a model, okay? So what next shows is a real data, okay? It's wine data. So, and the wine data and the number of column, the column information here it shows, okay? So it's regarding the certain class of wine. So here it has 3 classes of wine, okay? And it has a lot of features for the wine. And then you can use those data based on the data, and then you can predict if a sample is class 1 wine or class 2 or class 3 wine. Okay, so that's what this part does. And for the class label, then it converted to number, that use the unique to, here it shows, etc. And here, what we can see, the total number of samples is 178, okay, based on the brief description of the data frame. And then next, we already quite familiar with this. We needed to train and test. We need to split the original data into train set and testing set, okay? So in this case, you also needed to identify what are the features and what are your target value, etc., on your original data frame. So we find this and we do 70 to 30 split. And after that, so for this part, it just shows you can do, so belong to pre-processing. Previously, we also discussed, you can also use different ways to do, you can also use different ways to do what? To normalize your data or to standardize your data. So what we call that is scaling. You need to scale your data. Is it to scale data? And generally, we would like it to be 1 to 0 to 1, that the range. Is it all like 0, 1 to 1 range, some kind of like that. Okay, and in order to do that, there are multiple ways. One is you call it minimum maximum scaler, okay, from the SK pre-processing package. So here it shows. And the second way is we do standardize, okay. Standardize is you use the standard deviation and a median, is it to follow the normal distribution kind of the concept. So here you can also choose with the standardized scaler, okay? And then we can, so you have that standardized scalar object, then you feed the model, and then you transform your model. So that's what we already learned. And here it shows us, okay, what's about the maximum minimum scalar, is it normalized or you standardize, is it? And what's the next part? Because last class, what we discussed, one of the important feature in machine learning is you needed to do what? To feature selection. So select meaningful features, because a lot of time you may have a number of features. Is it a lot of features? And some of features may not play some important role for your training and testing and prediction. Is it? Then in that case, you want to filter them out. Is it? So today we will see the examples how to do that. And the last class, we also mentioned that regarding regularization. There are 2 types of regularization, L1 and L2 regularization. And we already know L2 regularization mostly used for what? Used to penalize your weight, is it? To try to play the role to penalize certain weight in your model training, etc. And there is another regularization, we call it L1 regularization, etc. L1 regularization, sometimes it can do the feature selection, it can benefit feature selection, because it's at this to obtain some sparse matrix, then it helps that with the L1 penalize. And the major difference between these two is one is the sum of the square of the weights. The other is just a sum of the absolute of the weight. So that's a major difference. So over here, we are going to use a logistic regression, okay, model. And you specify, okay, the penalty, instead of L2 over here, I'm going to use L1 to try with my example, etc. And then let's see what it did. And select features, there is another, for the feature selection, you can also import this package, sklearn feature selection. And there is a model called selector from model. Okay, and with this model, it can also tell you some information about how important your feature is, so that you can apply it to your feature selection. Okay, so let's see how are we going to do this. So you're going to apply the selector model to the logistic regression. Okay, this C1 is for the regularization penalization. And here is the penalty. I am going to use L1, and then you can start your training as a fit your model, okay? And over here, then, did you see, you can call the get support function. Okay, the get support function is to return an array. A return array, the array, what it does tell you, the array returns true false. And the true false is regarding what? Is regarding the feature importance. Okay, compare with the other features important. So if it is true, that means that feature is important in your model training. So you should take it. If it is false, that means, yeah, you can throw it away. Yeah, so you can say, after you, if you apply this selector from model and align it with the L1 penalty, and then you call the get support, it will give you some feature selection feedback, Yeah, so this shows if you use the selector from model, then you can use it to filter out certain of your features. And with this, it also tells us the coefficient of your model, And over here, we have 3 lists, And you mean, why should you have 3? That's because over here, we have 3 classes, okay? It's multi-class, it's not a binary class classification. And because you have 3, so normally it's just, if this is red wine, and the other 2 may pink wine and white wine, Then the other 2, you don't differentiate. You just say it's not red wine or it is red wine, So that's why this first one may tell you if it's red wine. And then the second one will tell you if it's pink wine. The third one will tell you if it's white wine, So that's why you have 3. Because normally you will just have one list of your coefficient, Yeah, so that's over here is because we have 3, that's why we needed to do one versus of the other, okay? And then based on the information, and you want to do the total feature in this case is 13. That means you have 13 columns of X for the training and the testing data, column. And the selective feature only going to be 10. If you take a look over here, true and false, because that tells you who is important, And so how do you do that? So this is just pure Python coding, that, and so not a lot of new things. And then you want to filter out those features, those not important feature, is it? And how do you get it? So here it shows you code, is it? How do you pick which column you want to keep and you don't want to keep, is it? And then regarding that, then you can filter out the features. Okay, so here it shows you filter out the features. And with this removed features, is it? Then you can further do your training, is it? Further do your training. And we continue use logistic regression, is it? But this time, what we are going to train our data is not the complete set, is it? We already take off those non-important feature for our model, is it? And you can see the accuracy, is it, for training and for testing. So that's the general information regarding this part. And over here, for this plotting part, what it shows is you can also find the weight coefficient, the relationship with the C parameter, okay, the hyperparameter C. And over here, the list of the 13 features, is it? List of the 13 features. And from this, you can see the C, is it? With the change of the C value, it does impact the weight coefficient of your logistic regression training, is it? Because your logistic regression, you want to find the optimal weight, is it? And if you take a closer look, you will find like this, like those features, is it? And it does vary. The value does vary with the change of the C value, is it? C value, okay, from negative 2 to from 10 to the negative 5 to 10 to the positive 5, and it does change the weight value training when you select different C value, is it? So it does impact, but for some of that, the impact is quite small, is it? So if you take a close look, like some of that, is it like this quite yellow one? Is it this total one? And did you see it's almost no impact? And if we take another look, you will find that is, did you see the total one, the non-flagrant pro? And those three are one of the values. No matter how you change your C, the weight, it's just there. Is it? So the adjust of the C won't change that. So that means also not important features. Is it? So this diagram also once again prove our assumption. And what next shows is about how do you apply certain feature selection algorithm, is it? And also over here, like this diagram, it shows if you change the number of features you plug it in, is it? It shows, it doesn't mean the more number of features you have, the better of your training result will be, is it? So because over here it shows the accuracy, is it? So it's just at a certain level it helps, is it? Because if you don't have enough feature, then you may have some bias issue, is it? But if you have too many, you keep increase, won't help your model. So this one does again prove our assumption. And the next one shows you can also use K nearest neighbor. Yeah. So last class we discussed that new model, is it, to do. So what the K nearest neighbor, what it does, it's not a supervised, unsupervised learning algorithm, is it? And if you apply that over here, we can also find, okay, it gives you some training result, is it? And over here, what it shows is if you use just the selected feature, is it? So in this case, you take off some of the features. You can see the accuracy, yeah, it does drop a little bit, but it's not that much. It's still above certain percentage of the accuracy, so it's still acceptable. So over here just shows the feature selections that it can place a certain role. And over here, what the next one shows you, I'm not sure if you still remember, with random forest, one of the nice thing for using the random forest is it can do feature selection. So random forest, you can also collect some of the feature importance data from random forest. And in order to do that, here it shows, is it? So you just use random forest for your model, is it? And then you do the fit, is it? And after you do the fit with the training, so how to collect feature importance, it's through this parameter. So you just call the feature importance parameter. And with this, and then you sort that. And then you sort it. And it will give you the feature importance, is it? And from this, you can also see, yeah, the last couple of that the features are not important. The percentage within the complete feature importance summary, the percentage is quite small, is it? And even from this bar diagram, we can also see their importance is not that important, is it? So you can also then filter out the non-important features, non-important features, and then do the training. So this is the